Hey everybody in Algebra 1 world. In this video I'm going to be talking about direct variation. Basically when something relates exactly to the other. So like how tall I am versus how wide apart my arms are. Shorter people are going to have shorter distance between their hands when they stretch them out. So this is kind of just called, excuse me, direct variation. Basically this can also be seen when you're making money. If you have a job that's say pays you $7 an hour, then how much income you have will depend on how many hours you work times 7 times your income. So that if you work, let's see, hours, income, if you work 1 hour you'll make $7. If you work 2 you'll make 14. If you work 3 you'll make 21, right? And they'll keep going. It is a direct relationship between the two numbers, or between the two variables really. So this is our direct variation equation. You're always going to have something like this. Y varies directly with x. I should probably write that. Y varies directly with x. Okay, y varies directly with x. So y equals some number times x. Doesn't matter what that number is. Could be 17, could be 29, could be 2 over 9, could be 568. Just any number. This number is called your constant of variation because that is what is making them vary from each other. This is how they differ. Okay, you're going to be using these things, and especially this equation, so make sure you get it in your brain. Okay, I'm going to run through 3 examples really fast for you guys. So with direct variation, we want to know if these equations are direct in these. So again, don't forget, direct variation, y equals kx, y equals some number times x. In this example, I have y equals 3x. So y equals some number times x. So yeah, this one is direct variation. Over here, I have 3x minus y equals 0. And I want it to look like y equals kx. So what I can actually do is it doesn't look like direct variation right now. But if I add y to both sides, then I'll have 3x equals y, which is the same exact problem as that one actually. So then, yes, y equals some number times x or some number times another variable. So then, yes, that is direct variation. In this case, I have y by itself, so I don't need to solve for it, but I have 3x plus 2. This plus 2 right here is keeping us from having direct variation. You cannot have plus or minus any other number, it's just some number times x. Okay, get used to using that variation equation. You'll also have problems that will give you a point, or give you y, give you an x, give you one variable and give you another, and you're going to have to write a direct variation. Not now, banana nose! You're going to have to write a direct variation equation that match these two things up. So if I know my variation equation is y equals kx, and I know y is 3 when x is 9, then I can substitute those into my equation so that I have 3 equals k times 9. And then I can find what k is by dividing by 9. Because that makes 1. 3 divided by 9 is 1/3. So if 1/3 is k, then my equation is y equals 1/3 x. Just put it back into your original equation. You may also have examples like this, where it's going to ask you, is this direct variation? You're going to have to look at every value in the table and see if it is the same k with all of these. And we're given that r varies directly with t. So if r varies directly with t, we know r equals kt. And I want to figure out what the k is for all of these, so that I can write my equation and y or r equals something times t. So I need to figure out what that something is. So I usually just extend my table, and I'm going to find the k for all of these things. Well, looking at my equation, if I want to find k, if I want to get k by itself, if I divide by t in the beginning, k equals r over t, and then I can just divide r divided by t and see what k is, just to kind of save you time. You can also just plug them back into your original equation, y or r equals kt, and solve for k every time. It won't be as fast as this, but you can do it that way. If this is a little bit more confusing, that's fine. Okay, so if I have r divided by t, 24 divided by 2 is 12, 36 divided by 3 is 12, 48 divided by 4 is 12, 72 divided by 6 is 12, and 96 divided by 8 is 12. So cool, since all of these came out the same, then yes, this is direct variation because all of the k's are the same. If I had one number different, If one of them came out that 40 divided by 4 is 10, then this would not have been direct variation. And now that I know that all the k's are the same, and I know r varies directly with t, then I can write my equation as r equals 12t. If you look at your table, if you plug in 2 for t, then r is 24. If you plug in 3, r is 36. If you plug in 4, r is 48, and so on and so on. So it works out. It makes sense. Good to go. There's our direct variation equation. Okay, that's all I got for you guys today. Hopefully this video was helpful in direct variation, and I look forward to seeing you guys in class again. Thanks.